Hey guys, Ranveer here from Beer Biceps. Today, we are going to break down a surveying technique that's super useful in construction and infrastructure, tacheometric surveying. You know how important it is to get accurate measurements, especially when you are dealing with large projects, right? Tacheometric surveying is a lifesaver when it comes to measuring distances and heights quickly and efficiently, especially in tricky terrains. Imagine you are building a road through a hilly area. Traditional methods like chaining would take forever. Tacheometric surveying swoops in to save the day. It uses an instrument called a theodolite, which is like a telescope on a tripod, to measure angles. By combining these angles with readings from a graduated staff, we can calculate distances and height differences with impressive accuracy. This technique is a game changer for surveyors. It's faster than traditional methods. Plus, you don't need to physically measure distances on the ground, which is a huge advantage in areas with obstacles or uneven terrain. So, whether you are building a road, a bridge, or even planning a new housing development, tacheometric surveying is an essential tool in a surveyor's arsenal. Stay tuned as we delve deeper into the principles and methods that make this technique so powerful. Let's get a little technical and understand the brains behind tacheometric surveying. At its heart, it's all about triangles, specifically similar triangles. Remember those from geometry class? The theodolite has stadia hairs, horizontal crosshairs in the lens. These line up with the staff held vertically at the point you want to measure. The difference between the readings on the staff gives us one side of our triangle. Using the vertical angle and the staff intercept, we apply trigonometry. The key formula is horizontal distance equals k times s times cos squared theta. K is a constant, s is the staff intercept, and theta is the vertical angle. We use these values to calculate the horizontal distance. Pretty cool, right? This helps in determining elevations and creating accurate contour maps. Now that we've covered the basic principles, let's explore the two main methods of tacheometric surveying, the stadia method and the tangential method. Both methods use the same principles of trigonometry but differ slightly in their execution. The stadia method is the most common and straightforward method. It uses a theodolite equipped with stadia hairs. By taking readings of the staff intercept and the vertical angle, we can directly apply the formula we discussed earlier to calculate distances. The stadia method is quick, efficient, and perfect for most surveying tasks. The tangential method, on the other hand, involves taking two readings of the vertical angle with the staff at different positions. This method is a bit more time-consuming and is typically used when higher accuracy is required or when the stadia hairs in the theodolite are damaged. Both the stadia and tangential methods have their own advantages and are chosen based on the specific requirements of the surveying project. Section 4. Instruments used in tacheometric surveying. Alright, let's talk about the tools of the trade. Tacheometric surveying relies on two primary instruments, the theodolite and the staff. The theodolite is the star of the show. It's a precision instrument that measures both horizontal and vertical angles. Modern theodolites are electronic and come equipped with digital displays and data storage, making measurements and calculations even more efficient. The staff, also known as a leveling staff or stadia rod, is a graduated rod that's held vertically at the point we want to measure. Stadia rods come in various lengths and materials, and the graduations are typically in meters or feet. When the theodolite is pointed at the staff, the stadia hairs in the lens intersect the staff at specific readings. These readings, along with the vertical angle measured by the theodolite, form the basis of our distance and elevation calculations. Apart from the theodolite and the staff, other accessories like tripods, prisms, and data collectors are used to enhance accuracy and streamline the surveying process. Section 5. Applications, advantages, and disadvantages of tacheometric surveying. Tacheometric surveying is versatile, used for topographic maps, roads, railways, and pipelines. Its major advantage is speed and efficiency, covering more ground than traditional methods. Ideal for large-scale projects and challenging terrains like hills, forests, and water bodies. However, it relies on clear visibility. Obstacles can hinder accuracy. Overall, it's an efficient, cost-effective tool for surveyors, engineers, and construction professionals.